Hey guys, welcome to Urban Campus and this is Ajay and today I'm going to talk about moment of force. So before going to proceed on the concept of moment of force, let's we talk about force. So one of the greatest scientists called Sir Isaac Newton, he gave three laws of motion in the year of 1686 in his paper Principia Mathematica. So those three laws of motion are very famous and very fundamental in physics point of view. So the first law is related to inertia, means he gives the concept of inertia from that first law of motion. And what is that exactly? Means every object will remain at a rest or uniform motion in a straight line unless and until there is no any external force. It means the velocity is constant. So if you don't apply any external force, that thing is either it's rest condition or it is moving with a constant velocity. So if that velocity is zero, then object is remain at rest. And if an additional external force if you apply, the velocity change because of force and the direction will be the as per the direction of force. So the amount of change in velocity is determined by the Newton's second law of motion. That is gives the definition of force. And what is that definition exactly of Newton's second law? It is a force to be equal to the change in momentum with a change in time. So when I'm talking about the momentum, it is very different than moment what we have titled, that is moment of force, and this momentum is different. So what is momentum? It is mass of an object times its velocity v. So when I'm talking about the times its velocity v means there is a change in velocity with respect to time. Definitely it is equal to acceleration. I hope that you know the basic definition of acceleration or the formula, that is change in velocity of time. So when the change in velocity time with respect to means directly with mass, means with when there is a mass of object times velocity v means it is a momentum. And when you multiply that with means basically the force is equal to mass into acceleration. So that is how the concept of force comes into picture. For example, to show this formula of F is equal to mass into acceleration, here I provided one example. You can see here as your right side there is one plane. It at its initial condition, that is zero condition, that x is defined as this position at initial condition, that is defined by 0 with time t0 with velocity v0 and m0. When you apply the force and that now plane is in now new condition, that is at displacement or a new position is at 1, so it is defined by x1 time t1 velocity v1 and mass m1. So apply now your that formula, that is force, it is mass into acceleration. And what is acceleration? It is change in velocity with respect to time. Then you can take mass m1 v1, which is its new position, minus its initial condition m0 v0 by t1 minus t0. Now mass is remain at its initial condition also and its new condition, that is why it takes as m and takes as common. And what is the remain? That is v1 minus v0 divided by t1 minus t0. Definitely what it is a change in velocity with respect to time, that is acceleration. So F is equal to mass into acceleration, which is given by Newton's with respect to his second law of motion. Now our main point is moment of force. So when we are talking about moment of force, it is nothing but torque. So I want to tell you that how this concept is important now and how it is related to those three laws of motion. So when you apply a force to any object, suppose that you are pulling or pushing any door, so definitely in that direction of force, that door will either it is pull or it is push. So door is it is hinged with it is hinged, so it will move either push or pull whatever as per your applied force. So what I wanted to say exactly, when a force is applied to an object, the it is what is its result? It will come into the motion, and its motion is in the direction of force. Now there are three possibilities. If that object is unconfined, and when you apply the force to the center of gravity of that object will have a purely translation motion, and it is described by the Newton's law of motion. Here unconfined means it is not attached with anything. Means suppose there is one ball and that ball is at rest condition, and when you apply the force, definitely that ball moves forward. That is, it is unconfined and it moves. That is, it got the translation motion. And definitely how will you define it is, or describe it by, means Newton's first law of motion. So if suppose that object is confined, means it is pinned or it is hinged, that is your door, the door is at one side, it is hinged. So when you apply the force, so it has some rotating motion, it can't translate. So how will you define? That is nothing but your concept of moment of force. You can see here is a bar which is shown in red color, and it has a distance L, and it is connected with point P, that is hinge. And when you apply force at the distance of L, so that force into, means multiplied by distance L, that is nothing but your torque, and that is nothing but your moment of force. Then if you have a question, if it is that thing is, when it is in a rotating condition also and in translation condition also, it is defined by Newton's third law. So now here we are talking about just second law. So you can see here the force is transmitted through the pivot, that is hinge condition. The details of the rotations depends on the distance from the applied force to the pivot, that is nothing but your torque, and torque nothing but moment of force, which is force into at a distance L. So here you can see the example of seesaw. So here is one cat which is sitting at one side, and it is hinged at one side, and the cat sitting at a distance of 3 meter. It has a weight of 20 Newton. So what is the moment at this? So as per the formula, it is a force into distance. So force is 20 Newton and distance is 3 meters. So moment is 60 Newton meter. And you can see here your daily life example where this concept of moment of force or torque come into picture while you pull the door or push the door. You can see here the people are sitting on a seesaw in a park. That is also example of moment of force. You can see other examples are also. So this is about the moment of force with one of the example. Thank you. I hope you understand the concept of moment of force. Thank you.